Hello everyone and welcome back to the channel. So today we are going to be solving the problem of the day and we are going to be solving it live. So it says minimum number of operations to make elements in an array distinct. Alright, this is Leetcode 3396. So let's have a look at what the problem statement says. It says you're given an integer array nums. You need to ensure that the elements in the array are distinct. Okay, so probably it has given me some sort of operation through which I can make sure that at the end of the day the elements in the array are distinct. What I can do is I can remove 3 elements from the beginning of the array. Okay, if the array has fewer than 3 elements, we remove all the remaining elements, so making the array empty. Note that an empty array is considered to have distinct elements. Return the minimum number of operations that you need to do in order to make the elements in the array distinct. And since this problem is an easy one, the constraints are comparatively very low, so I could literally brute force this, you know. So I could first things first. So how am I going to make sure that I have duplicates? You see, there can be multiple approaches. Since you know that the highest value of nums of I is going to be 100, you could take a vector of integer as a map. Okay, you could take a vector of integer as a map. You could name it frequency, and you could say you could give it a size of 100, and actually 101, since the largest element is going to be 100 itself. It can be 100 itself, and then you can assign every value 0, right? And then as you iterate through this array, what you're going to do is you're going to increase the frequency of every element. So something like this. So for int I in nums, what I'm going to do is something like this. I'm going to increment that particular index. So you see the first number that I have is 1. So I'm going to increment frequency of I. That means that my initially, for example, let's say this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's say this is my array. So initially all of them are 0, right? All of them are 0 because that is how I initialized my array. Now the first number which I'm getting is 1, so I'm going to increment it, right? This is how I'm counting the frequency. Now then the second number is 2, so this is going to become 1. Third number is 3, so this is going to become 1. Then this is going to become 1. Then the thing is 2 comes back again, isn't it? 2 comes back again. So before I actually increment the frequency of I should check if it's already 1. If frequency of if it's already greater than 0, then what does that mean? That means that the number which I have currently encountered is being repeated, right? The number which I'm currently at, which is this particular 2, it's being repeated. So what I'll do is I will take uh, a sort of a variable save, and why I'm taking this is so that I can sort of mark the last element which repeats. Okay, mark the last element which repeats. So right now 2 is repeating, and which index is 2 at? It's at 0, 1, 2, 3, 4. But what I'm doing is I'm iterating through the nums array like this. So I'll just very quickly change this to uh, this sort of a technique wherein I'm iterating over um, all the indexes, and I'll say current number is equals to nums of I. Alright, and rather than saying frequency of I is greater than 0, I'm going to say frequency of current is greater than 0. So, you know, because current is my current number, which is 2. And if it's already greater than 0, what I'm going to do is I'm going to save the index. Okay, now 3 is also repeating. So I'm going to update the save by 3, because you see at the end I have to make sure that the array has all distinct elements. So this would become my save index, then this would become my save index. Okay, and then 5 is new, 7 is also new. So at the end I will have this index as the last problematic index. All right, so what can I do? Then I'm going to see something like this. If I remove this part 1, 2, 3, if I literally remove it, do I have, again this is the question, do I literally have to remove it from the array? No, because this is a very common pattern in problem solving. Whenever a question says you have to do something, you don't really have to do that. You just have to simulate doing it. Okay, you just have to simulate doing it. So what I'll do is, rather than taking another new array and pushing back all the elements inside of that new array except for the first three ones, and all of that stuff, no, I'm going to do is, I already have the frequency, right? And let's take a moment and then let's completely fill the frequency array. So we encountered this 2, so this 2 is frequency 2. Then we encountered 3 two times, so this is going to become 2 and then 3. Then I have 5 and 7, so 5 and then I have 7. You see what I'm going to do? After this loop is done, I'm going to again iterate through 1 to 0. Okay, I'm going to again iterate from not from 1 to 0, sorry, from 0 to n. And then over here, what I'm going to do is, I'm going to simulate removing this, then simulate removing this, because I sort of remove elements in numbers of 3, right? And while I'm doing so, I need to do this step, since this is the last problematic index. So I need to remove the numbers till I reach this. Similarly over here, this 4 is problematic, so I actually have to remove everything, right? And then this is already all good. So yeah, okay. Again, why do I have to iterate? No, I don't even have to iterate. I can just, this is index 0, 1, 2, 3, 4, 5, 6, right? So I can just return 6 divide by 3, because it's going to take me 2 operations, right? So yeah, something like this. Return return safe divide by 2, divide by 3 actually. And in order to just round it up, I think I'll have to round it up, so I'll just do +2 over here in order to round it up. Okay, now yeah, so the last problematic of my internet is not working. Let's give it a second. Over here, my last problematic index is 0, 1, 2, 3, 4. So I should return 2. Put 6, why? Safe +2 divided by safe +2 divided by 3, something like this, right? Gets accepted. If I submit this code, then it should, okay, so this is not being passed. So 2, 7, 15, 1, 5. Okay, so yeah, a very good test case. This actually lets us know that if I remove this particular window, this is not actually my last problematic index. This is, you see, this is. So if I remove these 3 numbers, then this is all good. Yeah, this is all good. So I shouldn't this is not my problematic index. So how should I, this then becomes actually a pretty simple sliding window, sort of sliding window sort of a situation. So let me just remove all of this and let's start from the very beginning. Okay, keeping this case in mind, what I'll do is I'll take a map. Okay, I'll take a map, int comma int mp, and I will take a set. Why am I taking the set? So that I can store the numbers inside of the set which are repeating. Okay, which are repeating. Then uh, for int I in nums, I'll do is I will increment mp of I plus plus. I'll do something like this. And then, for example, if I encounter something which is already there in the map, if mp dot if mp of I, if it's already greater than 0, if it's already greater than 0, then that means I'm encountering it for the second time. So what will I do in this case? I will one thing, I'll put it in the set. So st dot insert whatever that number is, I. Okay, yeah, sounds good. Then I'm going to remove numbers in pairs of 3 until I have all distinct elements. Now you see, why did I take the set? I took the set because when you see, I'm going to decrement the frequency of these three elements. Okay, so as soon as I do that, the frequency of 15 is going to become 1 from 2, and then since it becomes 1, I will remove it from my set. So my set is actually going to become empty, and as soon as my set becomes empty, it lets me know that my array is now unique. Okay, zabardast. So I'll do something like this: int operations equals, it's initially 0. I'll do is for int I equals 0, I is less than n, I plus plus, simple brute force approach sort of. uh, okay, then what next? I need to remove elements in counts of 3. So okay, why don't we do something like this? I plus equals 3, and something like mp of, would it work? No. What if I have less than 3 elements? Then I'll break out if I have less than 3 elements. Okay, sure. Okay, so mp of, what I'm going to do is I'm going to say mp of nums of I. I'm going to decrement it. Okay, I'm going to decrement it, and okay, I'm going to see two things. If that number, was in the set, so if st dot find nums of I, if it was present in the set, is not equals to st dot n. If it wasn't if it was present in the set, and the frequency of that number now after decrementing has become 1. If it has become 1, then what I'll do is I'll just simply remove it from the set. So st dot remove, I think it's remove or erase, maybe erase, st dot erase nums of I. Right, I'll remove it from my set. And similarly, I'll see over here, if st dot size, if it becomes 0, or you can say if st dot empty, then I'll just return ops. Okay, yeah, but I need to check this particular statement after I have removed 3 elements, right? So what I'm going to do over here is I'm going to do something like this. So for int I equals, sorry, for int j equals 1, no, j equals 0, j is less than 3, and j plus plus, I'm going to do is nums of I plus j. Yeah, that sounds good. I plus j, nums of I plus j. So in the first iteration it's going to remove the current number, then plus 1, then plus 2. So 3 numbers in one go. And then we increment the I by 3, so it goes from 0 to directly 3, because you in the first iteration you have already processed 0, 1 and 2. Right, pretty simple. If st dot size equal 0, return ops. But then there's going to be that particular case, for example, if this was 15 as well, so you will have to remove these 2 elements as well. Yeah, so I can say something like, if j is less than 3, and actually, and I plus j should be less than n. Yeah, this sounds good. This is a very good safety check in my opinion. Okay, perfect. And return ops over here. So this safety checks actually makes sure that you do not go outside the index. I haven't defined n. Int n equals nums dot size. Right? It makes sure that we do not go out of bounds. Shaji, why are we failing? Why are we failing? Why does it return 0? If st dot find nums of I plus j is not equals to st dot end, so if that number is present in the set, and mp of nums of I plus j has become 1 after being, oh sorry, I will have to put this inside the loop as well, right? Obviously, yeah. So I will have to do something like this. Yeah. Okay. And then this is also going to be I plus j. I think this is going to be enough for today. This is going to pass, I think. No, 0, still 0. Why? MP of numbers of I plus j. If MP of I is greater than 0, you insert it into the set, else you do MP of I plus plus. Yeah, okay. Then operation 0, I is less than n. Then you do this particular loop 3 times with nums of I plus j minus minus. So this sounds good. And if that number was present inside the set, st dot end, and now that the frequency of that number has become 1, you remove it from the set. Then when you do if st dot size, actually we are not actually incrementing operations anywhere. So what we should do is what? When should we increment operations? After this line, I think. Yeah, because if you need to return 0, you are going to return it from over here. Why does it say 1 2 3? Acha, so actually plus 2, no. When should I ops plus 1 would actually be wrong, right? Because you need to return 0 in this case. So, or maybe, yeah, sure, ops plus 1, and I can have this statement before the for loop one time. So if st dot size is 0, just return ops, so 0, right? Makes sense. I think this should pass all the test cases. It does. I hope it passes all the hidden ones as well, and it does. So this was it from the problem of the day for today, and we could actually we could optimize this, but then that's not really needed since the constraints are very low, right? So over here again, the space complexity is O of n, because in the very worst case, you're going to store all the elements inside your map and set, and since you're iterating through all the elements as well over here, so the time complexity is also going to be O of n, right?